Yo, YouTube. What's up? So, be doing a video on buffer overflows. Learn how to get started with buffer overflows. So, I just thought, I mean, these are just fucking, god damn it, they're so disgusting. But I thought I'd make a video on them because I thought it was somewhat fun. I guess I don't know. I'm not gonna be going over these easy ones because this one's, now that you've got all the background information, it's like it goes into uh a char buffer array of 14 allocated bytes, and then it gets the buffer. So it gets from the so if you know what the gets function does in C, it just takes input from the command line and stores it within this string or this char array. So yeah, obviously it doesn't have like a maximum allocated value, so if you put anything over 14, then it'll spill out, and it'll spill out into the variable 0, right? So it shows you right here the stacks. Through the bottom of the stack, which save registers, volatile and variable, and then you have the buffer. So anything that flows out of the buffer, it'll take up the stuff in the end variable, right? Because it goes down the stack. And yeah. And then here, so this is the first one that you actually go into. That's like you have to actually do stuff with. So I'm gonna get into this one. Let me connect to this fucker. Let me clear that out real quick. I was just testing the pwn tools. Let's get. All right. So the first one I think we're doing is we're gonna be doing overflow 2, I think. So yeah, overflow 2. Or I can do overflow 1 real quick just to show you what I'm talking about. So if we do int overflow and we pass it, it'll ask, we're gonna say you have changed the value of the variable, so it spills out into the variable, right? So 1 second, getting a cough. Okay, I'm back. All right, so let's see, what was I doing? Yeah, I was just we can look at the code. I think so. Yeah, so obviously, like I said, the gets function just puts it and takes it into this char buffer, and if you put anything over 14 characters or bytes within that buffer, then it spills out in the stack and takes up the variable. So we can just hop out of here. All right. So I don't think this isn't really anything too wild. Gonna run it and see what happens. This is the normal function. Okay, so what's my desk wiggling all around? What the fuck? It's because I moved this chair. Okay, there we go. All right, so let me look at this .c file real quick. So we got here. So void specials, your special. So I think it wants us to get the special function at run, and we're taking a char buffer with gets exact same thing, and then we just want to overwrite this pointer here, and the pointer is just going to be an address. So because it points to an address and it has it run, right? Function pointer type of dealio. So we want to overwrite normal. And the way we're going to do that is we're just going to run this in GDB real quick. Function info, or info function. Functions info, is that how you do it? I think I say the command right here, I think. Info functions. Alright. So we want it to run the special function, and we can read its address within the static analysis here, because it's not actually running. We just have it in debug mode. We haven't actually run it yet, whatever. Anyways, so we know this is little endian because it's using x86. So I'm just gonna write this out so I can analyze it in my head. And actually, because we're gonna want to print it out. So we're gonna want to print out 4 bytes or 14 bullshit bytes. So I'm gonna do a times 14, and then we're gonna concatenate onto that. We want to concatenate the bytes in little endian form, so it'd be x67 slash x 05 slash x 40. Pretty sure that'll work, unless I'm retarded, which chances of me being retarded are pretty likely. Oh, I forgot. I'm missing a. Okay, go on what love is. Okay, looks like I'm retarded. Am I retarded though? So we want to overwrite the address. The address we want, which is right here. Okay. 67, right. 0540. Let's just add a couple more zeros onto this real quick. Even though I don't think that makes a difference. God damn it, motherfucker. I forgot to put a goddamn parenthesis here. They enter twice. That's weird. I'm just gonna do it like this because it's not working for some reason. Okay, there we go. All right, I don't know why. I don't know why that wasn't working. Oh, I think it's because um I don't know. Oh, it's because that's why. Because it doesn't. It takes the input from when you put it in, and if you do this, it'll output it, and then this will take it as input. Oh, because it's using the gets. My bad. Okay, yeah. So yeah, that's basically how you do it. You just want to do 14 bytes. So I just put a random letter A, because it doesn't really matter what you put in at to fill up the fucking buffer, unless you're doing some other stuff, which we'll go through in a second. And then I put the address, which is in little Indian form, so it goes, fucking backwards, I guess you could say. But what is it called? By the most significant byte. Um, so it goes the most significant byte goes last. Yeah. Oh, it goes least. It goes by least significant byte. I'm pretty sure is the term for it. Going by least significant byte. And then we're just using Python to just print it out to the console. And then we use the OR operator for fucking shell to run this fucker. So that one was pretty easy. But if you've never really done any buffer overflow, you probably thought that was a little bit complicated. I don't know. These other ones get a little bit rougher. Did I explain that properly? Let me know if I'm explaining this properly. Okay, in GDB also, when I was using this, all I did was list the functions out so I could see the addresses for the functions. Like if we want to, we can run the normal function, or not the normal function. We can run the other function, which there's no real reason to do that, but we can run it real quick. We don't need these extra 0 bytes. So the other function is 93 0540. So we can run that real quick. This is the normal function. Oh no, wait, what the fuck? Why did that give me an error? Oh, because there's a slash right here. Alright, why is this here? Who knows, right? So if we cat func pointer.c, not supposed to be to access these functions, right? They never get called within the actual program, but because we buffer overflowed it and replaced the address pointer right here, we replaced the address that pointer is pointing to with the address of our choosing. You know what I mean? Anyways, so overflow 3. All right, so in these, you want to try to get user 2 privileges. So you want to set your REID, which is if we do ID, we want to set our IDs to 1001, right? Or 1002, because let me actually show you that. Because user 2 is REUID set to 1002, right? So their user ID is 1002, user 3 is 1003. We could, set it to 0. I mean, we could try. I don't know. That'd be pretty funny, but I'm not going to do that because that's cheating. Maybe at the end I will. We'll see. So we can cat open buffer overflow.c. Take a look at this. So int main, it prints f, echo your program out, then runs a function called copy underscore arg, and takes the argument from the command line. So when we entering it in the command line, like I thought we were doing the last one, then it allocates a 440 bytes to a char buffer, uses string copy, and copies string. So the thing that we entered into the thing, or the argument that we entered, it copies that into the char buffer, and then it prints it out. So this is obviously where we want to try and run our shell code, is going to be inside of the string copy function here. And I'll show you how to do that and how to find out all the arguments. So I'm going to run through. So we know it's 140 characters right here. So we're going to start with 140 characters. And I'll show you what I'm talking about. So I'm just going to pull this in right here. Let me get rid of all this bullshit. And we're just going to print A. I'm just going to do times 140. It's going to be a lot more than this, but we're just going to keep going up because, yeah, it's going to be more than this. It's going to be like, yeah, because the return addresses, and we're going to have to go over the other fucking things within the stack that are allocated to it and overwrite them until we get to the return address. And then we can overwrite the return address and put our own address in so we can run our shellcode. See, let's look at this. So run. Okay, so print it out. Let's just go 150 because I don't. So we sig seved. Yeah, run that. Okay, so at 154 here, you see how it's printing 4141? That's the hexadecimal number for capital A. So we just want to keep going up until. So over here, let's see. So right here, program received signal seg v, so segmentation fault, right? We seg faulted right here, and we are inside main. We want our thing to seg fault inside of copy copy underscore arg. So that's where we want to seg fault is inside of here. Okay. So once we do that, then we're good to go. So not there. And then we'll know how to calculate the offsets of our shit in a second, which obviously I'll go over. So no. So we're overriding the return address right here. See that? Okay, there we go. So at 159 is when we override the return address, and then it goes back to the previous address, which is in here. So we want to do 158 as our fucker. So 158 is our thing we want to do. Is going to be our fucking total amount of bytes that we want to have. And then, so we want to do, we don't want to use A's, obviously. We want to use NOP instructions, which is 0x90 is a NOP instruction and x86 assembly, right? I don't know if you know that or not, but we can generate some shellcode. The shellcode on here actually doesn't work. What the fuck? Wait. Okay, give me a second. I'm gonna go find the shellcode I used last time. Alright, yeah, I think I'm gonna use this guy's shellcode over here. This is the one I used last time, so. Yeah. Let me check. This is pretty sure it's the one I used last time. Let me check it out. Let me pull this into Python 3 and use a length on it. okay or fucking not? Is it because it has these goddamn new line characters? You fucking kidding me? Alright. Length 52? No, that's definitely not the one we want. Where's the one I thought was 40 length? Final code, no. It's not the one I'm looking for. Object dump, no. Tester show code, no. Is this not the one I used last time? I guess not. Okay. Step was a 50. I think it was 40. It was 40 last time. Because the other one was 30 and it wasn't working. Let's take a look. So yeah, they recommend using, or they like give you this one to use. For this shit, that shit doesn't work. You just like all it does is just give you this illegal operation instruction or something. So why don't we look at actually looks in the shell code. Um, shell code for breaking out of shell. Here, I'm gonna go find some shell code to use for this. I'll be back in a second. Yeah, it wasn't that site that I was looking at. It's this one right here. For yeah. So if you want the shell code, just come to this website and you can find it right here. It'll just execute /bin/bash, and yeah, so pretty cool. Anyways, what was it doing? Oh yeah. All right, so this is 40 bytes here, so we can use the length inside of Python to get the bytes. So this is 40 bytes. So we know this is 40 bytes. So when we input our shell code into here, we want to add it. So that means right here, so we have minus 40 from 158, which will be, leave us with 118. Let me get rid of the shell code right here. Alright, so 118, we want to try and use up a good amount of this right here. Well, we can actually just minus 6 from that because we're only going to have 112 actually. So we can use, let's just say like, I'll just use 100 right here. So times 100. So 100 NOP instructions right here. And then we'll have a bunch of these fuckers. And then we'll add a couple more NOP instructions at the end here. So let me zoom in here. /x90 times 12. So that's 100, and then 12. And then we can add our return instruction, which we'll add right there. Which I'll do that in a second. For now, that should be Gucci. That'll be good, yeah. And then we'll add a return back there at the end. Or actually, oh, I forgot to add the set RUID. Let me add that. Yeah, so we're gonna want to use this. What's our UID? I do, so oh, I'm fucking. Alright, it's user 1, so we're gonna want to set our user ID to 2002 or 1002. So let's quit this, use pwn shell crap to make that. Let's calculate its length. 14, okay. So this is 14. We're gonna want to add that onto our payload right here at the start. And we'll just minus 14 from here. So we'll just say 86. And we can leave everything else the exact same. And then we want to calculate our return address, or shell code here. And so let's gdb dot slash buffer overflow. Let's run with that. What we need to do 18 here. Here, I'm pretty sure I do 18 here. We'll see. We'll see if it works or not. Then we want to inspect. So we want to inspect the so this is we're inspecting the stack pointer, and we're expecting 100 bytes at the stack pointer minus 200. So minus 200 from where we are now, so minus 200 bytes from where we are now. We're going to inspect 100 bytes. So we can see our so we have our NOP slope is what they call this, no operation slope. And then it goes into our fucking bullshit here. So 3-1. Is this our bullshit? This doesn't look exactly right. X31 FF. Yeah, this looks a little bit sketchy. I don't know why. Maybe it's because alright, let's reinspect this. I don't know. That doesn't look exactly right to me. I don't. 31 90 90 3 EA. Then we go back. Then we go back to our NOPs right here, and we got more NOPs, and then it goes back to the rest of the fucking addresses and shit. So we can just put this as our return address. Wait, 1, 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why are they 12 long? Something here is acting weird. I don't know. Am I inspecting this wrong? No, pretty sure that's the I saved the command because that's what I did last time. I don't know. That's strange. Am I doing something wrong here? No, actually, no, I don't think I'm doing anything wrong because it's supposed to be 6. I think I'm good here. Yeah, this will be good. I don't know, just to me it looks a bit weird from the last time I looked at it, but maybe I'm just stupid or something. I don't know. So we're gonna want to do plus 12 here, and then plus. We're gonna concatenate on. Goddamn mousepad, you fucking shit ass fucking. God damn it, this is cancer. Okay. Like, I just want to be able to see it. God damn it. Whatever. 0x. Jesus fucking Christ. 70/x. Okay, I'm not gonna do it right here. I'm really gonna kill myself if I have to do it right there. Let's just do it down here. So /x 70. slash x e2 slash x ff slash x ff slash x ff slash x 7f. All right, so it should be 6 bytes here, and that should work. That should be the return address we want to return to run our shell code. Let me make sure. We took from like right over here, right? 70. Yeah, it's in the middle of our NOP instructions to run our shell code. Okay, this should be good. What did we do? We did 12, right? So 18. I have to change that to 11. I don't know, but we'll see. I think this will work. Dot slash buffer overflow. Nope. Let's try changing this to 11. What about 13? Something going on here? Here's a program that echoes your output. Pretty sure we did it right. Zero x 05, and then our stuff starts x86 or x90 times 86, right? Then we come all the way down here, and then we add on another slash x90. 1, 2, 3, 4, 5, 6. That's right. 12. Yeah, this should be right. Hmm. Just gonna try up in the numbers. I don't know. Cause yeah, this looks right to me, except unless I wrote the address wrong, which is really the only option for me to be wrong here. So 70 E2, and then it's just a bunch of Fs, and then 7F. Yeah, I mean, that's right. So, I don't think I did my calculations wrong. This XEA. This is what it is right here. Minus 14 would be 98. So 86 plus 12 is 98. Plus our shell code. Yeah, no, this 98 is all we have for NOP instructions here. We have 98 bytes for NOPs, and then all of our shell code, which equals up to 52, or 54, I guess. Yeah, 98, and then we minus 86, we're left with 12, and then minus 12, we filled up everything and attributed the address correctly. Minus, yeah. So we're left with 12 and minus 12 already. Then we do 6 bytes for our return address to change overwrite the return address. Yeah, that looks good to me. I don't know. I mean, let's go back into so gdb dot slash these are all in the copy args. Oh, what the hell? What's gonna huh? Wait, let me calculate this real quick. This should be 54, right? Let's take a look at it. Yeah, it's 54 plus 86, so plus 86. 54 plus 86, 140. So this should be 12. Okay, I'm gonna go find out what I'm doing wrong real quick. Okay, I'm back. So basically, the reason that it wasn't working, and I was so confused why it wasn't working, is because I guess I had typed in the return address wrong. I just ended up typing in this address instead, and maybe I formatted it wrong. I don't really know. Um, but yeah, I guess maybe I formatted it wrong. I don't know, but this is the right address. Uh, any of these addresses work within the NOP statements. I guess I'd written mine wrong or something. I don't know, but so this is the payload I used right here, and yeah, it's a pretty easy stuff. Uh, anyways, if I just run it, I could just do a dot slash buffer overflow and then shift enter, and then it ran the shell and gave us UID user2. So we can now cat secret.txt. Oh my god, you did this, so cool. Thanks. And then we can just exit. Wonder, can we actually make set RUID equal to root? I just want to see this real quick. To be honest, I think it. Uh, where did we make the shellcraft here? So it ends at 0x5. Let's link this real quick. Lane. So yeah, that's our payload right there. So I want to make it one that sets our UID to 0. Uh, oh, I'm just inside the goddamn Python interpreter. My bad. Oh, and I did. God damn it. Alright, so this will set our UID to 0. Let's see how this works. No, let's make sure this is. I don't think that this does not look like the right amount of bytes to me. Probably because we got rid of a couple numbers, yeah. It's only 4, so we're gonna have to add 4 here, so let's do 90. That'll even us out byte-wise for the buffer. Let's copy that. Alright, dot slash buffer overflow. Oh, no. Yeah, that's weird. I guess it just said our. I mean, no, it didn't set our I did anything. But whatever, it doesn't really matter. I'm just gonna get rid of all this shit out of our fucking thing. Alright, let's get rid of all this bullshit. We're gonna want to do 3 next, if I remember correctly. Is there even a point in doing 3? It's just literally the exact same thing. I don't. Let me check. I'm pretty sure it's just the exact same thing. Oh, cat buffer overflow dot c. Yeah, this is just the exact same thing. Um, I'm. Should I do it, man? How long has this video been going on for? 36 minutes. Okay, I'll do it real quick because I don't think it should take too long. So it's just running this function concat underscore r, basically the exact same thing we did last time, and then it just string concats the string onto this buffer. So again, like last time, what we're gonna want to do is overflow the buffer until we get placed back into concat underscore arg, and then we want to do one less than that, so we know the exact buffer overflow. And then once we do that, we can calculate our nops, shellcode, and all that other stuff, and indexes, right? So it's pretty easy, to be honest. We can just open this up and then printf. I'm just gonna do. I'll just do a, and we know it's 154, so I'm gonna do 6. I'll do 166. There's no specific reason why I'm doing this. I just know it's gonna be an extra 6 in this anyways, so I'm just doing 160. Gee, yeah, I'm just doing 166 because that should be good. Run. So sig faulted, so we're already on our way to buffer overflowing this. So I think that's a what? 1, 2, 3. So it should be 169. Should be the overflow here. The address. Or maybe actually 170 is probably what it is, right? Yeah, so 170 overflows us out. So 169 is going to be our offset we're working with here. So 169, our shell code. What the fuck? Oh, I got rid of the shell code. Are you fucking kidding me? Is it in here? Oh yeah, it is. Okay. That's gonna be our shell code. So we're gonna want to do this as 90 times, we'll just say 100 for now. So minus 100, we're left with 69. It's gonna be minus 54 because we're gonna be adding on our shell code plus exit. Let's pwn shellcraft to make SUID 103. We'll be adding that onto there. What happened to our print function? Oh, it's rounding? Why the hell is it doing that? Okay, there we go. This should be, this should be 54. Yeah, so 54, so minus 54. We're gonna be left with, let's see, 15. So we're gonna actually minus 6 off of that. And then we're gonna be left with 9. So we're left with 9 extra bytes. So we can just add that onto here. Let's do /x90 times 9 plus And then we're gonna want to do our reversal right there, but we're not gonna do that for now. Okay, god damn it, this shit is cancer. Let me actually get rid of this for now. Let's do 15. Alright, let's get back in here. So let's run this. Yes, we're cool with that. Alright, let's examine the stack pointer. Just got minus 100. Alright, we're gonna do a little bit more than that. Minus 200. So we see our knop sled right here. So I'll just do it right here, where right when our knop sled is about to end, goes into our shellcode. And I'll just do it right there. That looks good, man. I mean, we'll see. I'm known for fucking this up, so /x90 /x e2 /xff xff ff x7f. So change this to 9 plus plug and play. Alright, this should just be a plug and play type of deal here. Hoping. Overflow. Nice. First time around, baby. That's why I'm the goat. I can cat out secret.txt. So I'm the buffer overflowing fucking god right there. Alright. This. Alright, thanks for watching the video. If you want more videos, let me know. Peace out.